Now we want to discuss the range values of the 6 trig functions. The range values of the functions are the same thing as the output values of the functions. For sine and cosine, if we are looking at the range values on a number line, the output values of the function would be as small, could be as small as -1, go all the way to 1, and the largest value that sine and cosine could take on as an output value would be +1. We want to discuss why this would be. When we are looking at our x, y, and r as the sides of a right triangle, r, it would be the hypotenuse. And the hypotenuse, if you remember, would be the longest side of our triangle. If r is always the longest, then if I was looking at the relationship between r and y, r would always have to be larger than y. Or the sides could be equal. But r could not be smaller than y if r represents the hypotenuse of this right triangle. So r must be either larger than y or it could be equal to y. If I look at this as it corresponds to sine, sine is y over r. If y is always smaller, and r would either be larger or equal, well, if they are equal, that would be 1. And if y is the opposite sign, if y is negative, then we would have -1. So we could see that if y and r are equal to each other, with y being positive, I would get a +1. If y is negative, I would get a -1. But if y is smaller than r, let's look at an example like 3/4 or 4/5. If y, the top value, must be smaller and r must be larger, notice that these values would all be less than 1. So we can see how we could pick up values in between 1 and -1. We could see how we could pick up values that are less than 1. But why is -1 at the bottom here? Well, if, let's say that y is negative. If y is negative, then let's say that we have a -3 and a -4. Well, these values here would both be larger than -1. So if y is negative, then I would have to be larger than -1. So the smallest value that I could have would be -1. The largest value I would have is +1, and anything in between could potentially be a value for sine. So sine has to be something between -1 and +1 because of the fact that y is always smaller and y is on top for the sine function. The same thing would be true for cosine, because x is also a leg of our triangle. X and y both excuse me, x and y both must be smaller than r. And if x is very, very similar to y here, then the same must be true for cosine. Since x and y are both smaller than r, then the relationship for sine and cosine, the relationship would have to be the same. So cosine and sine are both between -1 and 1. What about cosecant and secant? Let's pick a value out for sine. Let's say that sine, we have to pick a value that comes from -1 to 1. Let's say that sine is equal to a +1/2. Then the cosecant value would have to be the reciprocal of that. So if I pick a point that exists between -1 and 1 for sine, cosecant would be the reciprocal of that. And you notice that cosecant isn't going to be larger than 1. When I flip a fraction, we get something that is larger than 1 here. So if I flip a fraction that's smaller than 1, we get a fraction that is larger than 1. If sine is equal to, let's say, a -3/4, Negative 3/4 would be in between negative 1 and 1. Then cosecant, when I flip that fraction, would be a negative 4/3. Both of these, this is larger than 1, and this value here is less than negative 1. So for cosecant and for secant, the values of that would have to take on the opposite values of sine and cosine. In other words, starting at negative 1 and going toward the left, and starting at positive 1 and going toward the right. So if sine and cosine are in between negative 1 and 1, then cosecant and secant would have to be either smaller than negative 1 or equal to negative 1, or larger than positive 1 or equal to positive 1. So the reciprocal values do exactly the opposite as far as their outputs go. So that's why we get this in interval notation. We have negative infinity all the way to negative 1, and then we union that, or we skip over everything between negative 1 and 1, and then we pick up again from 1 to positive infinity for secant and for cosecant. Now when it comes to discussing the range of tangent and cotangent, tangent is y divided by x, and cotangent is x divided by y. Now this time we do not have a restriction on which one can be larger and which one can be smaller. X and y are the legs of a triangle, and the only restriction we had for the triangle was that r had to be the largest number, or the largest side of that triangle. X and y can have any sort of relationship with each other. X and y could be equal to each other. Y could be less than x, or y could be greater than x. We also never had a restriction that said that x and y cannot be 0. If y is equal to x, so let's focus on tangent here. If y and x are equal to each other, so say for example 3 divided by 3, then tangent could be 1. If y is less than x, so the top number is smaller, then we could have something that's less than 1. And we could also say that y is negative. So let's say that y is negative 2. Well, then now we are less than, we are actually greater than minus 1. Okay. Also, we have y could be larger, so we could have something like 4/3, which is greater than 1. We could also have negative 4/3, which is less than negative 1. So we really have all of these possible values for what could happen with x and with y. Also, let's say that y is 0. If y is 0, then we could have 0, let's say, divided by an x value of, let's say, negative 4. Then we could actually take on a value of 0 as well. We could have all sorts of possibilities for how x and y can relate to each other. So as we start to put together all of these different scenarios, we can see that really x and y, when I form a fraction of these two values that could be any two values and have any sort of relationship, that we could really pick up anything that's less than 1, greater than 1. We could even pick up values of 0. So we actually end up picking up the entire number line for tangent and also for cotangent. If tangent could take on any value, then the reciprocal of that would also take on any value. So tangent and cotangent, with all the possibilities for x and y and how they relate to each other, the output values are unrestricted. So anything from my number line from negative infinity all the way to positive infinity could represent the output values for tangent and for cotangent. In example 7, we want to use what we just discussed about the range values of functions to decide whether or not each statement is possible or impossible for some angle theta. So for part A, we want to know, is it possible for sine theta to equal to 3? And the answer for this would be that it is not possible. And the reason why it's not possible is that sine must be in between -1 and 1. Here, sine is equal to positive 3, and that is not possible for sine to be greater than 1. It has to be less than or equal to a positive 1. So what about cosine theta is equal to negative 0.96? Is that possible? And the answer for this would be yes, this is possible. This is possible because cosine values must become in between -1 and positive 1, and 0.96, negative 0.96 would be right before -1. So it is a little bit larger there than a -1. So that would be possible for cosine value to take on that value. Cosecant theta equal to 100. Is this possible or not possible? And the answer for this would be possible. That is possible because cosecant theta must be greater than or equal to 1, or cosecant theta can be less than or equal to -1. And here we see that this satisfies the first requirement, cosecant theta being greater than 1. So that is possible for cosecant theta to equal to a positive 100. Is it possible for cosine theta to equal -2 and for secant theta to be equal to a -1/2? Well, let's first check here. Cosine has to be larger than -1 or smaller than positive 1. So this right here is not possible. So the answer for part D there would be not possible. Is it possible for cosecant theta to be -2 and for sine theta to be a -1/2? So let's check cosecant. Cosecant has to either be larger than positive 1 or cosecant can be less than -1. So this satisfies the second requirement where cosecant is less than -1. So that is possible. It is possible for cosecant to be -2 because that is smaller than -1. Let's check the next one. We see that we're given the reciprocal sine is also negative, so the fact that they're both negative, that's a good sign. And the reciprocal of -2 would be a -1/2. And let's make sure that sine is in the allowable values. The sine values have to be in between -1 and positive 1. And -1/2, of course, sits right in between -1 and positive 1. So that does work. So this would be a possible value for sine. So both of these would be possible values for cosecant and for sine.